Okay. Sorry, I have all of these little pop-ups on my screen now. Okay. So good afternoon. Welcome to the SAS via Transition Topics office hours. The two links on the screen I did mention for those who are just joining, Rachel's going to be dropping those in the chat here, so you are able to click on them. And then we can repost them a couple minutes in for anyone who missed those links because they're joining a little late. And the same goes for Oren's notebook. So just a few administrative announcements before we get started today. Please do remember to stay muted to minimize interruptions. And then use the Zoom chat feature to ask questions related to our office hours topic today. Team members will be answering questions using the Zoom chat feature and then verbally throughout the session. But we do ask that you put all questions in the chat feature because it helps us keep a record and make sure that anything we didn't get to, we're not missing anything. And then all Q&A are published. So they'll be posted after the meeting concludes to the DNA portal. So we do want to make sure that we're not missing any of those and we have a record of everything, and then everyone can benefit from the questions asked. So all meeting materials, including the recording, will be made available in the CCSQ DNA portal. And then as a note there, just give us a little bit of time to turn those materials around because we do need to 508 them and make sure they are compliant for all. So with that being said, we are going to kick things off today with working with data visualizations with Oren, and I'm going to pass things over to him now and stop sharing my screen.
Excellent. Thank you. Okay, can everyone see my screen?
Yes.
Excellent. All right, so we are going to talk about visualizations in Python today. And the reason why you want to learn about this is that we are talking about it specifically in the Databricks notebook as opposed to a dashboard. And when we want to make something that's really, really nice, you probably want to go the dashboard route. But even if you know to create visualizations in just your Databricks notebook, it's going to help you make your result much better, easier to understood. It's going to make it much more user friendly. And it's something that you want to know about just so you can create a few things in your notebook just to make your notebook clearer. And the idea is what we're going to do, we're going to look at the Databricks visualization tool, and then we're going to go in depth into Plotly, primarily the histograms. Okay, so to set up, we're going to install some libraries that we need. I'm installing Bamboo Lib. You don't need to worry about that. That just has a few data sets I wanted to use. It just happened to have the data set I wanted to use, so I'm just installing that. We have Plotly. That's going to be the main visualization tool we're going to use. We have Kaleido. That is Plotly's that helps you download Plotly visualization. So you can download to your S3. And then we're going to download this S3FS to also help with the downloading process. And you can see about an hour and a half ago, I ran the DB utils, and we have the stuff, we have our things that we need to get done. We're gonna do some imports also. Plotly works best with pandas. So we are gonna install pandas. We're gonna make sure we have pandas working. And if you're working with Spark data set, there isn't Spark doesn't have so many packages that supports visualization. There is one that I'm familiar with that we're not talking about today. And then there's, of course, the Databricks visualization tool, their own stuff, which works on Spark. So one thing to keep in mind is that when you're doing visualizations, you're probably going to be working in pandas, and pandas can only support data sets that have a limited size. Also, I'm going to throw the notebook in the chat there. Yep, I'm importing Bamboo Lib. I'm importing NumPy because I want to do some mathematics. We're importing Plotly, and then we are importing stuff from Kaleido so we can do the download. And then I am just taking this Titanic CSV file, and I'm using that for the data that we're going to be working on. Created two data frames of it, largely because when I was working, I used one name and then I had another name. That's why I did that. But it's basically a data set about the passengers on the Titanic, talks about the fares, how much they cost, talks about which classes, talks about all sorts of things about those people that are on the Titanic. Okay, so let's start with the built-in Databricks tools. So the first thing is Databricks data profiles, and those let you view information about a data frame. And this data frame can be either Spark or Pandas. And it's going to show you what columns are there. It's going to show you whether they're numeric or string. And then for numeric columns, it's going to tell you information. For character columns, it's going to tell you information. And you can change the order of the columns based on number of criteria. And let's start with a Spark data set. For the Spark data set, I am stealing a file from Derek. He has a file called billionaires data, and I'm reading in here, and I'm doing the display. And when I do display, when it starts off, it shows me the table first. And what I can do is I can click on this plus button. It's going to show me visualization. And it's going to show me a data profile. Since I already have a data profile set up, let's look at that. Some of the things you can do is you can do sort by. You can change the order if you would like, or you can go here. You can change it to it's alphabetical. You can see whether you want to do it by most missing or something else. You do non-uniformity. It's telling me also that I have the types of files I have. I have 4 integer columns. I have 15 string columns. And if I want to search for something, I can put it in here and it would show up. And you can do regex, and that's useful when you have like a table that has like 300 columns in it. For ours, it doesn't matter so much, but like, yeah, if I had 400 columns in this data frame, I would want to be able to search for it. Not sure why they call the columns features instead of columns, but whatever, it doesn't matter too much. Okay, so let's start with the numeric one. For the numeric, we have 4 columns: rank, final worth, age, and birth date. And even though birth date is a date, it is still being shown up as a numeric. And then we have ranks. Ranks is just the rank of the billionaire. So you can see that for rank, we have 2,640 unique values. You can see for age, we have 2,575 unique values. For example, birth date 2,564. And then you can see the number missing. For the age and birth date, you can see we have a small amount of missing. For rank and final worth, we have none missing. And then you've got the mean and the standard deviation of this. And yeah, for something like rank, doesn't really make sense to have it as a numeric here. It sort of give me bad data because, I mean, rank just is the rank of the billionaire. So, knowing that somebody's the 500 is the 500th highest is useful, but it's not like I would want to look at the means and say, you can come to a conclusion based on that. But anyway, we have the means, you have the standard deviations, we have the zeros, the min, the median, the maximums, the data type, and then here's just the histogram showing me what the data looks like. For the character ones, reasonably similar. You've got, for example, here we've got category, and then you have the percent missing. And for category and last name, there's none. But when we get the country, we get the first name, we get to a bit more. You can see the number of unique values, which is useful when it comes to category. Knowing there's 18 groups is helpful. When it comes to first name, a bit less useful. And then you have the top. This would be, if it showed up right, this would be the top value. And you'll realize you can't see everything. Yeah, it doesn't look like you can actually make this larger. But you go here, you can see that the main category of billionaires is finances and investment. And then you can see the frequency of the top value. So apparently there's 372 people in that category. And then the average length, that's just the length of the value. So finance and investment that has, I don't know, 5, 4, 7, 9, 10, maybe 20 characters or so. Then I would have a value of 20. Yeah, not so particularly useful, but I guess sometimes if you wanted average length, maybe for something it could be useful. maybe you have a field that should only be 8 characters, so you want to look at that. And if you have a 7.5, you know something's wrong. But then you also have the custom tells you data type string, and then you have this line graph, which isn't very useful. And you also can look at the raw data and it'll show you how many people. So you can see there's 370 people with this, 270, 224 in manufacturing, and so on and so forth. You go down, you see other things. You have to be worried. You have to worry about the chart. You can see that if we go here, it's starting at 0.64 with healthcare, which probably isn't the one you want to start with because there's other ones that are bigger, but that's the way it works. And that is basically how a data profile works. I have another case of it in for the pandas data set, and you can see it can be much the same thing. We have 5 integer, 2 float, 5 string, and you can see our values. You can see we have passenger ID. You can see we have whether or not the person people survive. The P class, which is the passenger class, whether they're in first class, second class, or third class. You can see we have age, apparently whether there's a sibling, the fares, and then you can see some of the character values. Okay, so let's talk about Databricks data visualization. So it supports a ton of visualization types. It includes one like bar graphs, line graphs, histograms, and less common ones like sunburst sequences, word cloud. And it can let you set X and Y columns. It can let you group. It can let you update legends, change colors, and change formats. And again, to create that, you would go to the plus and you would hit visualization. And this shows you a bit about what it looks like. So here is our bar chart. And you can see that it is grouped by, so you can see we're looking at the number of millionaires and how much the total wealth is. You can see that we are looking at gender, female or male. The female is on the left, the male is on the right. And you can see we have whether or not the people are self-made by the colors here. Okay. Let's go. You can see there's 2,640 rows, and you could probably do a download. And let's go to edit visualization to see what we did. So here is the visualization editor. And what we did to create the visualization is I chose the bar chart, the bar graph. And you can see I can choose whether I want things going vertical or horizontal. I chose vertical, but if I wanted it going horizontal, I could just click that and it would change. You can see I chose an X value, an X column of gender, and you can only set one column there. And then you can see I have two Y columns of the final worth. I have the sum and the count. So the count would just tell me the number of billionaires in those groups, and the sum would tell me how much money they actually have. And then you can see I did a group by self-made. So you can see that's why we have in here we have gender to do a graph, and then you have self-made columns showing up here. And then the legend, I have it that it's normal. I could stack it like this, and then it would look like that, and you would see things like this. Bit of a mess. So I'm gonna turn it back to disabled. But you could do like that. I could normalize the percentages, and then you would see a percent instead of an actual count. And then we can go to the x-axis. And here I could change the name. I could change the scale in theory. I mean, for this, it'll only do one. And then I can change how things show up there. For Y, what we did is again, it's going to be linear, but we changed the name here. And what we could do is we could set the value, the start value and end value. So maybe I only would want to see something like 0 to 300. And then it would look like that. And you can see how these things change. And if I were to hit save, it would actually change. And I'm going to turn it back to automatic. I don't think I want that. And then for the y-axis, also we changed the name, and you can see like that. This is the series. So we have 4 series because we have two y-axes for the counts of billionaires and for their net worth. And then we also have the group by. And you can see here, I changed the name and the names are showing up there. And then I'm also showing up where I'm also changing where the y-axis goes. So you can see I have two y-axes, and the one on the left is the number of billionaires, and the one on the right shows how much money they have. Here I have colors. I just chose the automatic one, but if I wanted to change a color, I could change it like I could change it like I don't have gray yet. I could change it like that, or if I knew the numbers of colors, I could do a change right here. And then we just have data labels. So I'm gonna hit cancel because I don't want any of my stuff saved. I'm gonna hit yes. And that is a bar chart. And then we go here, you can see that we have a combo chart right here. And you can see that we have lines and bars. And just to give a quick look there, you can see the visualization type I chose was combo. I have my X being age, I have my Y's. And yeah, it looks like that. I'm not gonna spend too much time on this because I don't want to run out of time. And then you can see I have a funnel chart. And this is, again, this is going to show me the rank. So if you go to the funnel chart, you'll see that I have the rank as the step thought, the step column. So this is the richest person right here is number, and the value column is right here. That's why the first one showing up is the richest person, second one's the second richest, third, the third richest, so on and so forth. If you go down, you can see we've got a funnel chart right there. And then here, this is just one using pandas. And you can see we have a pie chart. And just really quick, what we did here is we have, I said the pie, X column is survived, Y column is passenger ID. I could change this to something different and I would get different results. I could change it to sum, I could change it to average, and so on and so forth. I use the group by as sex, and that's why you see both of these right here. And then I have the direction counterclockwise. I could change it, and then these would all presumably look differently. And then I could set the way I wanted the legend and all that stuff. Do I have anything else interesting? And then here is the scatter chart. And yeah, you can see my X column is fair, the Y column is age. So this is fair by age. And then I have a group by sex. You can see different stats. And you could select that if you wanted. You see the X-axis, you can see the Y-axis. You could change series if you wanted. You could do all that stuff. And just to give you an idea how it looks like, you go to visualization. So here's where you could choose any of the ones you wanted. And you can see they've got, I mean, it's not huge, but it's a reasonably large amount. Yeah, which is the histogram, keep it at R. And you can see here's where I would change things. If I wanted to do a bar graph, I want to do a histogram, it's going to give me different things. It's going to let me choose my number of bins. I can choose my X column, and then I can set my X axis. I can set the Y axis. I can set colors. I can set data values. If I wanted to do a different one, maybe I wanted to do a bubble. It will let me choose my X and Y. It will let me do a group by, maybe a bubble size, and so on and so forth. Yeah, I mean, there's a lot here, depending what you want to do. And unfortunately, we only have so much time to discuss it. Okay, so we talked about that Databricks data visualization tool. Let's talk about Plotly. And the first question you probably have is why Plotly, not Matplotlib? So historically, Matplotlib has been the first visualization package that Python users learn, simply because it's been around since 2003. And so a lot of people learned it, and it's just a boulder effect. The more people that learn it, the more things that are in it, and the more people have to use it. Plotly is a relative newcomer, but it's designed to be a bit more informative, interactive, and web ready. and it doesn't hurt that they won the 2024 Databricks Customer Impact Partner of the Year award. So you can know that they work well with Databricks. The way I feel about it is Plotly is easier to learn. They have better documentation. They have more functionality. And if you're starting from scratch, like a lot of us are, it's better just to go with Plotly and not worry about Matplotlib because that way you'll just have something that's easier to use. But you do have to keep in mind that if you go somewhere else and you work with people that have legacy code, probably going to be using Matplotlib. But that's a problem for a different day, not today. Okay, Plotly Express allows a whole bunch of functions. They have a whole bunch of maps. I'm not going to read all of these, but this is a list of all of them. And this is just Plotly Express. So Plotly Express is their basic package, but then they have another one, Plotly Graph Objects, that gets a bit more code intensive. And we're not going to do too much of that today. And that would let you code more things if you wanted. So lots of functionalities. So the first thing we're going to do is we're just going to print out a figure. And this isn't going to give you a result. This is just going to tell you the things that you can look at. And you can see some fields that are being are showing up. And you can see what things are set at. So it gives you an idea of what there are things that you can edit. Okay. And to introduce you to Plotly, we're going to do an in-depth creation of a Plotly histogram. We're going to use the Titanic dataset in a pandas data frame. And we're just going to create like 25 histograms using different options just to like give you guys an idea of what's possible. Okay, so the first one, this is just a basic histogram. So the first thing we're doing is we are defining a figure. We're using the PX that is that Plotly Express module, and we're using the histogram command. And you can see again, there's a whole bunch of things here that you can look at that tell you things that you can possibly update or edit. We're not going to touch on all of them. We are going to touch on a lot. The first thing we have to do is we have to define the data frame. And here we are defining it as CF Titanic, which is our Titanic data frame. We are setting the x-axis equal to age, and we're setting the title equal to age distribution of Titanic passengers. And yep, you can see, voila, we have a basic distribution. You can see the x-axis is the ages. You can see that the y-axis is the count. And you can see that we set our title. You can see that we didn't set count, so count is just whatever the default was. And the y-axis, we didn't set the count, so that's just the default. We set to the default, which happened to be count. And yeah, you can see the stuff. You can see there's some hover text. You can see how many are in a group. And we did define bins, so bins are assigned randomly. Okay. Here is another basic histogram. The only difference is we are using Embark. And Embark is a bit different because Embark only has 3 values as opposed to age, which has a number of different values. And yeah, you can see, again, it works reasonably well. You can see that you have whatever S's, that's the majority, you got 244 of them. C's much fewer, and Q is the smallest. Okay, for this next example, we are studying an X value and a Y value. So the X value is the age, the Y value is the fare. And because histograms are a really bad way of measuring this, it's saying us to the sum of fares. So it is going to show us how much the total fare was spent by an age group. So here you can see that for people 24 to 26, they spent $1,860. For this next thing, we are changing the ranges. So in the one above, we went from, well, that's not a good example because I think it's a different one here. We're just doing age to be the one above it. Maybe not. Okay. But we can do here, you can see that we have an age distribution by gender. And what we did was we set our range for the X from 0 to 150 and the range of the Y from 0 to 200. That's like this is 200. This goes to 150. And you can see that these are, yeah, obviously this wouldn't be the automatic one because we don't have very many 140-year-olds on the Titanic. And we didn't have 200 in any of the age group. But you could change this if you wanted to set to something different. Like we could change this to say like 30 and 60, for example. We could run that. And yeah, you would see our X stops at 30. And that means we would miss some of our graph because we would miss everyone that is older than 30. And we start our count at 60, and that's not going to cut it off because there's no group that's over 60. But if we set to like 30, you would see how it would cut things off. So yeah, depending on what you want to do, you can use ranges. This next thing that we're doing is we are going to change title fonts and colors. So here we are we are defining our histogram, we're just saying age, and we're going to do this update layout. And what we're doing is we are saying the main title to histogram with custom access. We are saying the X axis to age group. If you go down here, you'll see that is age group. If we go to the Y axis, you can see we're saying that's a number, we're defining that as number of people. And then you can see that we are changing the title font, we're setting that to a size of 30. So you can see this is a bit bigger. And then the font for the axes, that's going to be a size 20. You can see that's a bit smaller. And then we're changing the title font color to red. That's red. And then these are green. And yeah, and that gives you some color. And if you want to make the font larger or smaller, you can use the width and height option. And here we have the width. It is equal to 500. And the height we set equal to 250. You can see it is very small here. What we could do is we could set it to say, that's 1,500 and 1250. You see you have a much larger graph. So yeah, depending on how large you want it to be, you can just set this and it will change. You can also change the template color. Here we're taking that same one as before, and you'll notice that we are saving this as fig. That's being saved basically as a variable. And so basically, this when I run the show, it's basically showing this, but it's going to go from command to command. So in theory, if I were to name these different things, I could go back to something to an older figure. So if I named like the first one Fig 1, the second one Fig 2, the third one Fig 3, so on and so forth, I could go back to Fig 1 whenever I wanted. So in that regard, it is explicit as opposed to implicit. And that comes in handy here, where I am changing my update layout. I'm changing my template to Plotly Dark. And they have a number of different templates. You can find that here if you want to click on it. And it'll show you stuff. And you can see that the size is the same as before. But you can see that now it is black as opposed to what the color was earlier. Next up is updating legends. So here we're going to show two histograms. The first one, we are looking at it, we're looking at age, we're looking at color. I'm saying this and then I'm going to talk about later. We are studying a title, and then we are updating the layout. So we're going to set the x-axis title, we're going to set a y-axis title, and then we're going to set a legend title text. and then we're going to show it. That's going to be our first one. For the second one, we are still working with fig.show. So it is going to keep the stuff that is here. And we're just going to update the x-axis type. We're going to set that title text to new age group. And we're going to set the layout. We're going to set the show legend equals false. And what you can see is here's the first one. And you can see that we have our thing. You can see we have our legend right here. You can see our legend out of order, which we probably don't like. We're going to talk about how to change that in a minute. But you can see that we have age group. That was our first name. You can see we have number of people. And yeah, you can see we have a nice legend. And yeah, we had age of groups, and you can see our title was right there. For the second one, I've gone too far. So before we change the x-axis one, the new age groups in the second one, you can see that we've done that. We have number of people, age distribution, and you can see we have no legend. So just to go back up here, this shows you that there's a few ways that you can change the update layout. One is by doing it right here, and by changing the x-axis table right here, you put that in there and you can set the age group. But you can also change the titles by doing update x-axis and changing the title text. And obviously, more ability to change things here. But yeah, however you do it, they can both do largely the same thing. And if I wanted to get the legend back up, I could use show legend equals true, and I would be good. Nope. Before we had our legend showing 3, 1, 2 as the P classes, which probably not how you want to see the legend. It just looks nicer to do 1, 2, 3. So the way we're going to change that is we are going to use category orders. And we're going to set that tick, and we're going to set this equal to P class 1, 2, and 3. And that's going to order how the stuff shows up. And also, if we go up here for a second, we go here, you can see that this is 2, this is 1, and that's 3. So not only was the legend out of order, but also the data was in a weird order, right? Because here's G class number 3, here's 1, here's 2. We would like it to be 1, 2, 3 or 3, 2, 1 or something like that. So the category is going to sort that out for us, and then we just have some changes here. We're changing we're saying the x-axis titles to age group, the y-axis the number of people, and we're also changing the legend title text. So if we go up here, okay, that was age by ticket class before, and now we are still doing that. And now you go here, if we look at that, and you can see 1, 2, and 3, and now it is in order. Okay. Next up, we have the histogram legend order. And this is going to let me decide how I want the legend ordered. And I'm also going to talk about how to move the legend. So here we have recreated our histogram again. We have our x-axis of age groups, our x-axis title of age groups, our y-axis title of number of people. We're going to call the legend, we're going to call it age by ticket class, but we're going to set the order to reverse. And now you're going to see it goes 3, 2, and 1. And now we're going to take the legend and we're going to set the x coordinate to 0 and y to 1. We're going to see that now it is in the leftmost corner. And before it was over here. So definitely moved a little. And you can see that even though we changed how the legend works, the data is still organized as it was before. So only the legend got moved around. Okay. For the next thing, we're going to talk about how to change the legend text. And here we have this histogram. It's going to be age. We're going to set a color thing, which we're going to talk about in a second. And we're doing this lambda statement. And basically what it's gonna do is gonna update the names. It's gonna say that if the if the value was one, so if we go above, you can see that, well, okay, you can't see that there, but basically the survived column is a one and a zero, which is good news because you can use it for like correlations if it is one and zero, or you can use it for statistical analysis. If you want something that can be easily understood, one and zero doesn't work well. So here what we're doing is we're basically using this for each trace, and we're basically going to change it for each record. And we're going to say that if the value is one, then we're going to set it equal to name equal to survive. Otherwise, we're going to set it, otherwise if it's zero, we're going to set it did not survive. And then we're going to have our legend group as survival. And you can see we have our thing. You can see that the labels right there, we have survived and survival state status. So that is setting the name. And yeah, you can see that we have our picture right here. You can see we have survival status in the legend. And then we have do not survive, survived. And we go here. And yeah, you can see that that wasn't changed because we didn't change the data. We only changed the legend, but you can see of a much nicer legend. Another thing that you can do is you can change the histogram, you can change its color and opacity. And what we have here is we are looking at age. We did the color thing again, which we haven't gone to yet, and then didn't haven't gone to yet. We have set our categories to 1, 2, and 3. And you can see we have our x-axis defined, we have our y-axis defined, we have our title of the legend defined. And here what we're doing is we are updating the traces. We're going to use the marker, and we're going to create a pink line around some of this stuff. And if you look, you can see that we have pink lines around the group by using that marker. And you can see here's your P class 1 stuff, here's your P class 2, you have your P class 3. And you look at the legend, you can see that you have a marker. Now we have a line defining where the P class is on, which, you know, is it better than the colors? It makes it a bit nicer, right? If you had a line here, it would help a little. Otherwise, it's sort of all blends together. So just something to keep in your back pocket. And then we can also add an annotation. And the way we do that is you define the coordinate where you want to do it at, the y coordinate where you want to do it at. And it's actually not so bad because the x coordinate falls out based on your data. So basically what it's doing is when age is 25, it's saying the line. And when the number of people is at 325, that's where it's saying that line at. So that makes it easier, right? Because this is something you would probably do after you've created your graph, and you can use it to, like, show things that you want to point attention to after you've done your analysis, but for somebody else to look at. And yeah, and you can see we're able to set some text. So we're call that peak age group, and then we have an arrow going down to it. So in theory, if I was creating this for my boss, I could show Derek, look, the big group is the group of 20 to 30. And I can make it easier for him to see it. Okay, one other thing they have color sequences. It's not fully sure how useful it is. I mean, if you want things to look different than the standard, you could use that. Here I'm using plasma, and you can see the colors look a bit different than they would normally. And here we're just doing again fair as our X. And yeah, you can see, yeah, it looks a bit different than it would without it. Okay, let's talk about bins. So bins are one of the good things that a histogram allows you to do. It allows you to bin your data by a number of bins. So for example, here we are doing it by age. So in that first figure, I'm doing it as 20 bins. So I'm going to split age into 20 groups. They're going to be reasonably They're gonna have reasonably the same amount of ages in there. And I'm also going to do that by group with 5 years or more, 5 years in it. No, I'm sorry, I'm gonna do 5 bins of ages. So for all the ages, they're all gonna be split up into one of 5 bins. And just the wrong button again. Right, and we can take a look at this. So here you can see that we have the data in 20 bins. It looks a bit nicer. You can see that it was before we were looking at like 2 years at a time. Now we're looking at like 5 years at a time. So you can see it's a bit better. And then also here, this movie set to 5 bins. It's a bit unfortunate that the age is going to -10. I was able to figure out well, in this example, I didn't actually set the bin so that it is I didn't set the bins manually, so I did it automatically. For some reason, it's starting at -10, even though there are very few people in the world that are -10 years old. And it's also, and then everything else looks reasonably good. You can tell there's a lot of people that were from 10 to 30, good number of people that were from 30 to 49, and relatively fewer that were older or younger. Here is an example of us manually defining a bin. So here I'm defining bins with 0, 12, 18, 35, 16, 100. And it's basically the way you would think it works. The first bin is going to be 0 to 12. The second is going to be 12 to 18. The third is 18 to 35. The fourth is 35 to 60. And the fifth is 60 to 100. And and then second, we are defining the labels for it. So 0 to 12 is a child, 12 to 18 is a teen, 18 to 35 is adult, 35 to 60 is middle age, and 60 to 100 is senior. And then what we're doing in our data set, we are playing with the F1. You can see I got the DF Titanic. Yeah, I probably should change it to DF, but I didn't. And you can see we're setting the bin equal to the bins right here, labeled as labels right there. And now we're gonna have a new table, a new field, age group. And then here we're just creating one that's gonna be by ages. We're gonna have the color being age group. And then we're gonna set survival also in there. And yeah, you can see, I don't actually think I did anything with survival. I think having that in there was probably a mistake, but not a big deal. But you can see that we have right here, we can have our age group defined, and you can see that some of these bins are now defined by the group. So you can see that this first bin is purple, and that's a child. The second bin is like a child. The third one's a child. You see this fourth one that is a teen because teens are between 12 and 12.4. So you can see a bit of change there. Then you have this one. Then you would probably have something here if there were a lot of teens between 17 and a half and 19, which apparently there weren't. And you can see that even though there are some bins, the colors are based on the age group. One thing you can do is work with bar gaps, and bar gaps just create a gap between each bar in your histogram. So if you were to look at the data stock one, for example, you can see that we have spaces here between these things, and you can see we have our four things right there, and you can see these are relatively similar. And this is how it looks without the gap. And you can see without the gap, it's a bit messier, right? It looks like one big blob. So having that bar gap can help you there. Another thing to keep in mind are facets. What facets do is they will create multiple graphs for you based on that column, based on number of values in that column. we're using survive, so we only get two, but if we use like embarked, we get three. And if we use something with 10, we might get 10. You have to be careful because you did something like fair, you would get an insane amount, and who knows what use it would even be. But you can see what we did there. You can see we have our stuff, and that is the facet column that did that for us. One thing that we haven't talked about yet we've touched we haven't talked about yet are colors. And what colors do, it's going to separate something on that axis. So the color is going to set different colors for that text field, but also going to set X, which is age. It's going to split that into male and female. And we did the bar mode that is overlay. That's going to look a bit different than some other things. If you look at the third one, it was group, and that's going to be a bit more useful, as we're going to see. And then we're just setting the titles. And yeah, here we have a drop NA subset at age. That's going to get rid of any of the ones that are zero, which there shouldn't be any. Here we did an add a size equal truth. That's just going to give us the normal size, which we had already. And yeah, you can see these. So here you can see how male and female they're overlaid because they're both showing up like pretty much on top of each other. You see this is 77, that's 41. And then the second one right here, this was the grouped one, and you can see how they are separate. And this was just text. You can see how they got separated, how they are just they're just in different spots. The middle right here, the more is there. The fifth func is useful. That is going to let you define how you want the y to be. For example, if you want it to be a sum, or you want it to be a count, or you want it to be like an average or something else. And for this first one, we did sex and age, and we did not set his func. And the second one we did, and the third one we did, we set the orientation equal to H. And we didn't set the his func for the first one, so instead of using age count, it used sum of age. So we know that the male passengers have a sum age of roughly 13,900 years, which probably isn't so useful. Females, 7,286, also not so useful. And that is why we set the his func equal to count. And then we get the actual number of people, which is probably what we wanted. So we see 453 males, 261 females, and that should be good. And this is reasonably the same as that, only it is horizontal to vertical because I set the orientation equal to H. And then we have his norm, works similar to the his func. It just does things like the but now it's going to tell you like what it uses, not necessarily numbers. It might use probability. So here what we're doing is we're saying his norm equal to probability, and we said 25 bins, and you can see that all these bins are all going to equal. They're all going to add up to one. So you can see I got 62.5% there, 26.6% there, and so on and so forth. One thing you probably want to do is you may want to download your histogram. And to do that in Plotly, there are two ways to do it. The first is to go up here, and you can see these options. You can hit download as a PNG. And also, one of the things you could do here is you could make some of these changes. You can hit this to auto scale. You can hit this to zoom in or out. You can hit this to select something, or use a box select, or to pan. If you wanted to see a specific part of it, the one thing you could do is you hit the download, and voila, it downloads nicely. And the second thing you can do is you can use that library I was talking about earlier, which was it was Callisto or Kaleido. And but basically what we're gonna do is we have to define like this. We're gonna do something like that. We're gonna set the image equal to format. We're gonna save that somewhere. I'm going to specify my S3 path, and then I'm going to use S3.fs, and I'm going to basically just write it there. And if we run this, and we go to staff, find out. While that's loading, I'm going to keep on going. Okay, so there are other examples of Plotly charts. So that was in-depth thing, but you can do a histogram. But here's some other ones. This one is a bar chart that we can use. I set the discrete sequence equal to something different, and I have the axes set up differently. I have it vertical, I have a static column, and you can see that we have the results. You can see that the color scheme is different because I changed that color orientation. And then here, this one, this is a pie chart using graph object, and this is going to create hover text. So I can hover text over it, and I can set what I wanted it to show as. We have our legend. And then here we have a histogram. We created a combo graph. And when we did that, we are using that merge stall to create that box graph. And yes, you can see things there. And let's go back to staff now that we've waited a bit. And let's go and yeah, Titanic history, program history lesson 10. That's the file we just created. And I want to see properties, so I need to go up or down. And yeah, you can see what's just created. You can see that the thing I did before had created that. And also another thing you can do is you can do an animation. So this takes one of their data sets based on it looks like content, it looks like countries. And if we were to run this, it does an animation of how things changed from 1952 to 2007. And yeah, that is the lesson. You should, at the end of this, should have a better understanding of how to create visualizations in Python. You should understand how to use the Databricks visualization tool and how to use the Databricks data profile tool. And you should have a better understanding of what we can do with Plotly. Do we have any questions?
It doesn't look like any that have not been answered from the team. Orin, are you okay if I administer our post-session survey at this point?
Absolutely. I will
Okay,
stop
great.
sharing.
All right. Thank you so much to Orin, and thank you to everyone who participated today. I'm going to be sharing a poll here in just a minute. Um, okay, so that should be on your screen now. Please just give us your feedback so we can continue to make sure our SAS transition topics office hours are worthwhile and giving you the best information we can. And when you're done, please feel free to drop. But we want to say thank you for joining us today. Have a great day.